to look at how DNS works, I'm going to do two things. I'm going to pull up the browser first. So in Edge, I'm going to type in rtsnetworking.com. My website pops right up. So the question, when I type in rtsnetworking.com, how does my computer know where to go? How does it know the address that rtsnetworking.com actually resides at? The answer is DNS. That is the entire answer. So what I'm going to do is switch to a command prompt for a moment. In the command prompt, I'm going to type ping rtsnetworking.com. As soon as I hit enter, in an instant, you can see rtsnetworking.com is resolved to the IP address 185.230.63.186. So in milliseconds, my computer was able to take that name, contact a bunch of DNS servers, and get it resolved to an IP address. Well, that brings up the question, how? How does that process actually work? Well, let's take a look at the breakdown of what actually just happened. In this graphic, we have a few components. I have my client computer, RTS-client1. I have my local DNS server. I have this website, www.rtsnetworking.com. And over here, we have the root of the internet, which is always represented by a dot. Then we have the top level domain, com, and under that, we have RTS networking, and this is the IP address that RTS networking resolves to. So ultimately, when my client types in the rtsnetworking.com, it has to ultimately have that query passed all the way over here, somewhere on the internet, to be resolved and then returned all the way to itself. We need that to happen in milliseconds. So the process that actually takes place. The first thing that's checked when you query anything is the local client cache on your computer. The local cache is nothing but a list of names of things that you have recently resolved on your own machine. So if you go to rtsnetworking.com, it's going to temporarily be cached on your machine. Now, two commands you can use with this. ipconfig/display DNS. ipconfig/display DNS will show you what's in the cache. And if you want to clear this cache, there is ipconfig/flush DNS. Now let's switch back to the command prompt for a moment and we'll take a look at those. So in my command prompt, the first thing I'm going to do is actually type ipconfig/flush DNS. You'll see that says it successfully flushed the DNS resolver cache. Now, just for good measure, notice I have no space between ipconfig and the /. You can put a space and it executes exactly the same. So space or not does not matter. I only say that because some folks are used to typing this one way and I may type it a different way and then they're confused. So syntax for that space does not matter. What I'm going to do now is ping rtsnetworking.com again. So we know it's not in cache and it resolved to this 185 address. If I'm not mistaken, that's actually a different IP address. When I pinged it a moment ago, it resolved to an address ending in 186. Now it resolves to an address ending in 107. Well, if we run our ipconfig/display DNS, now I have a few things that show up here. Some of this is related to Office 365 and other things, but we don't care about those. This is what we care about. rtsnetworking.com. Well, that's the address that resolves to 186. You'll see record name, RTS Networking. So we know this IP address here resolves to that name. We know the name rtsnetworking.com also has this address that ends in 171. And it has this address that ends in 107 that resolves to rtsnetworking.com. So this name, rtsnetworking.com, has three separate IP addresses. The reason is primarily load balancing. DNS has this process called round robin, which means when some people connect to my website, they're going to get sent to the address that ends in 107. A few minutes later, other people connect, they will get sent to the address that ends in 171. A few minutes later, other people will get sent to the address that ends in 186. Does not matter what address you get sent to, they all host my website. So you're going to see the same website independent of which one of those you actually get sent to. And if one of those were to fail for some reason, there's no single point of failure. You would simply get passed to one of the other two. But notice this has a time to live of 2669. I'm going to hit the up arrow just to recycle that command, and I'm going to run that again. So notice rtsnetworking.com, now it's 2,574. I'm going to hit the up arrow and run that again right now. Now it's 2,564. This is in seconds, this time to live. So that means for the next 2,000 seconds, 2,000 plus seconds, my computer will remember that this name resolves to this IP address. After that amount of time has passed, then what's going to happen is this is simply going to disappear out of my cache. Once it disappears, if I go to rtsnetworking.com, it goes through this long resolution process we're about to look at, and it may now use this one or this one. Just depends on what the DNS server ultimately sends back. But the main advantage of this, if I'm on the rtsnetworking.com website and I'm clicking around looking on a bunch of different things, I don't want every click to have to go back to DNS and say, oh, can you look up rtsnetworking.com/demo/onsite or whatever the link actually is. The computer's going to say, oh, you clicked on the link for rtsnetworking.com, /sales. I know what address that resolves to because it's already in my cache, so it does not have to constantly keep going back to DNS. That's the first thing that's actually checked on your machine. Once you have the client cache checked, the second thing is the host file. The host file on your computer is actually a text file. You can open it with Notepad, and it's always in this location. C Windows System 32 drivers etc hosts. What you can do is actually edit that file. You can save something directly into it, and once you do that, your computer will forever resolve the name to address you saved into it. Well, to put a face to that, I'm just going to pull up my run box here, and in run, I'm just going to type C Windows System 32, and I'll just hit OK for that. You could keep typing the path out, or just navigate through your C drive here, open the Windows folder, you'll see System 32. Well, under that, there's a drivers folder, and under that, this etc, which does stand for etc, weird name, but there's a host file that shows up here. Now, notice this has no extension. That's why it has that weird looking icon. So when you want to open this, if you just double click on it, you can open it with Notepad. But if you do that, you cannot make any changes to it. For example, if I tried to put in 10.1.1.1 rtsnetworking.com, if I just go to File and Save, does not work. It forces a save as. So the only way you can actually modify this host file, I'm going to open Notepad, but I'm going to right click and run as administrator. Now this is open with administrative rights. Now you have to go to File, Open, and we'll just navigate. C Windows System 32 drivers etc. Now notice I don't see any files right now. The reason, it's looking for text files. I'm going to change this. When I select all files, you see everything in the list. And that's because the host file does not have an extension. So it's not a file type that would show up unless you choose all files. Now if I open it, I'm just going to look exactly the same. But this requires me to be an administrator on the local computer I'm trying to edit the host file, and you have to run your text editor as administrator. Well, I'm just going to put in 10111. I'm just making up an address, and I'll put in rtsnetworking.com. Now, if we go to save, we don't have a problem. Well, if I go back to my command prompt for a moment, in the command prompt, I'm going to ping rtsnetworking.com again. Fascinating. It resolved to that address, 10111. The reason, it checked that host file and it found a static entry for rtsnetworking.com. Now that's a bogus address. That's why it just says request timed out. Where we know, if I scroll back up, the previous command we ran, rtsnetworking.com resolved to these three addresses that we were seeing show up here. Now, when I saved rtsnetworking.com to that text file, it automatically purged this. So that had not been sitting there for 2,000 seconds. But adding that record to the host file wiped out the entry in cache because it was a duplicate entry. So that's why it just shows up as this 10111. Well, now I'm going to hit the up arrow just to go back through my command history. And I want ipconfig /display DNS again. Notice now rtsnetworking.com now resolves to this address, 10111. You can't get this back out to the internet now. It's going to keep using that bogus address. It's not going to go to the rtsnetworking.com website because this is in the host file. So it's going to keep saying, I don't have to ask anybody else where RTS networking is. I already know. So what happened, I saved it to the host file. It automatically populates it in cache. Well, notice here, the time to live is 0. Now that's a little weird that it's 0. That means it never expires. You could run this command over and over, and it's going to keep being 0 for the time to live for rtsnetworking.com. So this is going to be here permanently unless I edit the host file, which is what I intend to do because I don't want that entry. So I'm going to just go back here and just delete that. Now I left this open from before, so it's still the notepad running as administrator. But if I delete that line and save, now if I run that command again, ipconfig /display DNS, notice it automatically removed it. There is no rtsnetworking.com anywhere in the list. A bunch of other stuff because I use Office 365. Well, now if we ping rtsnetworking.com, we fully expect it to work now. And it does. Going to one of those 185 addresses. So back on the slide, that is the second location checked. If your computer does not have an entry already in cache or does not have an entry defined in the host file, which would have been pre-populated in cache, then your client computer has to give up and it has to pass this to the local DNS server to be resolved. The query sent to your local DNS server is a recursive query. Now, the fact that they use the word recursive, what that actually means, in layman's terms, I need you to help me out with this. Do you know what rtsnetworking.com resolves to? If you do not know, do you know who actually does know? And can you query that device or ask that other server? That's the recursive query. So when that gets passed up to your DNS server, the DNS server will determine if the name is local or remote. Now let's say this is a website name. So it's way out here on the internet. It's not your actual domain name. If it determines that the name is remote, it knows it cannot locally resolve that name for you. It doesn't store records for public websites out on the internet. The first thing it'll do, once it determines it's remote, it's going to check the DNS server cache. Similar to the cache on the client, if you have a coworker that resolved this name minutes ago, then that name would still be registered in your cache on your DNS server. If it is in your cache, sends it back to your client and you would be done. If it's not in your cache, It queries the root of the internet. Now, this query is an iterative query. Now, this is most often called a simple query. The way a simple query or iterative query works, it says, can you help me with this? If not, can you point me to someone that can? Where the recursive query, the DNS server assumes full responsibility to resolve your name, and it's going to ask everybody it can until it gets an answer. The iterative query just says, do you know who I can talk to? That gets passed to the root. Says, do you know where rtsnetworking.com is located, like the IP address for it? The root says, nope, I don't know RTS networking, but I do know the .com servers that host every website that ends in .com. That's the response sent back to my DNS server. So now my DNS knows the IP addresses of the .com namespace servers. Every public website registered in the world that ends in .com has a record on these servers. You can just imagine how large they would be. My DNS server now queries the .com namespace saying, can you tell me the address for RTS networking? It has that address, sends that address back to the local DNS server. My local DNS server places it in cache and sends it back to the client. Now, Microsoft always lists those as step 10 and 11. They actually happen concurrently at exactly the same time. That's really neither here nor there, but it does not wait to send it back to the client. Writes it in cache as it passes it back to the client. But now the client is aware of the IP address of RTS networking. If we were to flush DNS, so now I have no trace of rtsnetworking.com in my DNS because I flushed the cache. All this ipconfig/flush DNS does is actually take the time to live, and it ignores it and just wipes everything out of cache that it has resolved. If I ping rtsnetworking.com now, you can see the speed at which that worked. Now, we don't care that we get a reply. That's not important to us. DNS took this name and resolved it to that IP address. So before I fully removed my finger from the enter key, that name had already been resolved to an IP address. Everything we said in that graphic actually happened that quickly. Pretty fascinating.